in terms of what this one is concerned, this one says electrolysis of NaCl aqueous with inert electrodes. So again, we don't need to worry about the electrodes. They're not going to be part of our consideration. But now when we take a look at NaCl over here, it is now aqueous. So you now have to make sure you distinguish between NaCl liquid and NaCl aqueous, because both of them are in liquid state. However, when you look at NaCl liquid, that is equivalent to molten, isn't it? It's just melted material. However, when I have NaCl aqueous, what does that mean?
With water.
It's dissolved in water. So what this means is that this is a solution. And now this is going to be throwing some more complexity into your problem. Because now when I take a look over here and I look at this diagram, I have Na plus in here, I have Cl minus in here, and I also have H2O in here. And another way for you to know you have something that's aqueous is when you see the molarity. Okay? When you have something that is molten, there will be no molarity there. Now, why is this going to be something that is going to be important for you to know? And the reason is because now you don't just consider the two ions, but you also have to consider the water as well. Now, if I was to take a look at my data booklet right over here, would you agree with me that this is my sodium right over here? Okay? And then I also have the Cl, and let me erase this one over here, and my Cl is right over here. Okay? So far so good. But now you take a look a little bit down to the bottom, you see that there's a water here. So at this point in time, you have this one equation, which is for water. But if I look further down, and I go further down to the bottom, I also have another water here. Do you see that? This water is getting reduced. This water here is getting oxidized. So in this case over here, if I was to take a look, I want you to see how many equations have I actually highlighted. I've highlighted 4. Now what I'm going to do, just to help you guys out a little bit, is I'm going to circle the species that are going to be present in my solution. Okay, and my screen is a little bit small, but do you see the top 2 over here? I've got these 2 on the right that are circled. Do you see that? And then down here, do you see over here, the left 2 are going to be circled. Okay, those are what is present, and those are the ones that are going to be potentially undergoing a chemical reaction. Now your question is, which one? Now you guys have learned that you're supposed to go uphill, isn't it? So it's going to go up from the sodium. Now in this case, it could go up from the water. And it is supposed to go uphill to reach either this one or that one. Okay? So the question is, which one? So first of all, let's look at our options. So I can do the one that we've learned so far, which is, in this case, going from sodium all the way to the chlorine. That is my first option right there. Okay? Do you see it's from this side or on the left-hand side? And you're going up to the one on the right-hand side, which is what you've traditionally done. But is there another possible uphill reaction for the sodium ion? Yes, because now I can also have sodium going up to water, can't I? Is that also not an uphill reaction? Yes. So are those the only two I need to consider? No, because I'm going to change colors over here and I'm going to change it to green. We also have the water down here, don't we? So cannot the water go from here to here for my third reaction? Or can I not have the water go up to the Cl, and that is now my fourth reaction? Do you guys see that there's four possibilities? Now what I'm going to do is I'm just going to go through the long way of explaining things, and then I'm going to show you a shortcut. So what I'm going to do is I am going to write all of this down. So starting with the top. So over here I have Cl2 plus 2 electrons, giving me 2 Cl minus, and my E naught over here is going to be positive 1.36 volts. And then the second one over here is I'm going to have 1/2 O2 plus 2H plus 2 electrons, and I'm going to get H2O, and my E naught over here is positive 0.82 volts. Then I have down here 2 H2Os, oopsie, 2 H2Os plus 2 electrons, giving me H2 plus 2 OH minus, and I end up with E naught is equal to negative 0.41 volts. And then finally over here, my sodium, Na plus electron, giving me Na, and my E naught over here is negative 2.71 volts. So again, just doing what I just did before. I could have Na come up here for reaction number 1, or I can have Na go up here to the second one, reaction number 2, or I can do this one, water to water, reaction number 3, or water to Cl, which is reaction number 4. Okay? Now I want you, after you finish copying this down, you guys can put your pens and pencils down, because I care more about you understanding logic here. So if I was to take a look at reaction number 1. So reaction number 1, remember that the bottom reaction is going to go forward, the top one is going to go backwards, yes? So therefore reaction number 1, you would have 2 Cl minus, giving me Cl2 plus 2 electrons, and my E naught over here is negative 1.36 volts. Down at the bottom, I have Na plus electron, giving me Na, and the E naught over here is negative 2.71 volts. So if I was to add this together, times it by 2, I get 2 Na plus 2 Cl minus, giving me Cl2 plus Na, and my E naught is going to be negative 4.07 volts. So far so good? Okay. Now let's take a look at our second option, which is the sodium to the water. So the water over here is going to be H2O, giving me 1/2 O2 plus 2H pluses plus 2 electrons, and my E naught over here is going to be negative 0.8, I believe it was 2. And then now I have my sodium, Na plus 2 electrons, giving me Na, and my E naught is negative 2.71 volts. And then I'm going to multiply that by 2, and then I'm going to get 2 Na plus H2O, giving me 1/2 O2 plus 2H plus, and my E naught is negative 3.53 volts. Do you see that? So it's a little bit different voltage. So now what I want you to think about is, what's the significance of the change? Okay? Now I'm going to continue doing the third one. And so in terms of where the third one is concerned, do you see it's now water to water? Do you guys see that? So over here, I'm going to have H2O in equilibrium with 1/2 O2 plus 2H plus 2 electrons. And my E naught over here is negative 0.82 volts. And then I'm going to have H2O plus 2 electrons, giving me H2 plus 2 OH minus, and my E naught is negative 0.41 volts. So if I was to add this up now, I get, oh, sorry, is there 2 in there somewhere? Yeah, there's a 2 here. So this is now 3H2O, giving me 1/2 O2 plus H2 plus 2H plus 2 OH minus, and my E naught over here is 1.23 volts, negative. Do you see these two here? What do they become? H2O, 2 H2Os, right? So what does it make sense for me to erase this and just turn this into 1? Okay. Now let's do the last one. Number 4. So in number 4, remember it is water to Cl. Do you see reaction number 4? So over here, if I take a look at number 4, it's going to be 2Cl minus, giving you Cl2 plus 2 electrons. And my E naught over here is going to be negative 1.36. And then the other one is going to be 2H2O plus 2 electrons, giving me H2 plus 2 OH minus. And my E naught over here is negative 0.41 volts. So now if I add this all up, I get 2H2O plus 2Cl minus, giving me Cl2 plus H2O or H2 plus 2 OH minus, and my E naught over here is negative 1.77 or 1.77 volts. So, which one is the most likely reaction to take place? 1, 2, 3, or 4? Now think about this. See if you can logic it out. Remember, what's an electrolytic cell? It's a cell where the reaction is not spontaneous. So it means that you have to put effort to make the reaction take place. So in this case, if you take a look at all of these, so you take a look at all of these values all reflect how much effort is needed. So therefore, which one here is going to be the first reaction that is going to take place in all of these 4 possible reactions? Reaction 1, 2, 3, or 4. Think about yourselves. You're given 4 tasks to do. One task requires you to complete it in 6 hours. The other task requires 4 hours. The next one requires 2, and then the last one requires 10 minutes. Which one are you going to prefer to do? The 10-minute one. Why? It's the least amount of time, the least amount of effort. So these equations are like you. Okay? They have teenage angst like you. So which reaction requires the least effort? 1, 2, 3, or 4? It is 3. So in this case, when you take a look, this is the reaction that will take place first, because it requires the least amount of effort. So in this case over here, when you now take a look at this particular situation, the analysis now has to be which of these four is going to take place first. So, how are you going to determine that? So, if I go back to the previous page, and I go up here, it says general rule of thumb is to maximize the positive voltages and to minimize negative. So you want the least amount of negative voltage because then that's the least amount of work. Now, how am I going to do this? So if I was to now take a look, this is why I drew this out. So do you see how the top are the two on the right that I have in my solution? The bottom, I have the two on the left. So what I do is I'm going to draw a line in between right over here. And what I'm going to do, oopsie. So what I'm going to do is I'm now going to take a look at these two values. When I see these two values, this is now my shortcut. I take a look at these two values. Which one has the smaller absolute value? 1.36 or 0.82. So therefore, this one is going to be preferred. Now, if I take a look at the bottom two, which is going to be the preferred? 0.41 or 2.71? 0.41. So therefore, my prediction will be the two that are lower, that have the smaller absolute values. Now, does that reflect what you saw as the one that is the smallest? 0.82, do you see that? And 0.41, do you see that? Okay? Now, this is important though. You should not be doing this. You should not be dividing it here. Okay? Because now you split these two. Remember, it's contingent on you basically solving, making sure you know which two are on whichever side. So in this case over here, if you go back to the previous page, when solving for electrolytic cells, one needs to compare the solvent, which is the water, and the solute, and then you look at the lowest E0 value or the absolute value for the non-spontaneous reactions. Yep. Sure. I might kill your audio because apparently this is the loudest seat in the class. Huh?
I'm already taking video of Sheena's.
You're already
video.
taking a video? So Gleb's already taking a video. Oh.
Yeah.
Farther away.
I'll send to you.
I better not see it online.
You won't.
Okay? I don't want to sound like a duck for the whole world to see. Quack,
Okay.
quack. Okay. Now, when you now go over here and you take a look, what reaction is going to take place at the anode? And so remember, for this reaction, this is reduction. So this is your cathode. And for the reverse, it is oxidation. So it is taking place at the anode. So if I was to take a look here, which one's going on at the anode? It would be this water one. So this would be H2O in equilibrium with 1/2 O2 plus 2 H pluses plus 2 electrons, and my E0 over here is going to be negative 0.82 volts. So the other one is going to be H2O, 2 H2O plus 2 electrons, giving me H2 plus 2 OH minus, and my E0 over here is going to be negative 0.41 volts. So at this point, the electrons cross out. I have 3 H2Os, giving me 1/2 O2 plus H2 plus 2 OH minus plus 2 H plus. And again, what did we conclude that the OH and the H do? They combine to form water. So you now have this combining to form 2H2O, which crosses out to give me 1. So in this case, here are some things that I want you guys to see and what you guys want to come to realize, because you're going to be seeing this in your lab today. So when we take a look at this reaction, this is the negative, so the electron comes down and this goes up. So this one here is the cathode and this one over here is the anode. So remember over here, we said at the anode, you're forming oxygen, yes? And at the cathode, you are forming hydrogen. Do you see the coefficient 1/2 for the oxygen and a 1 for the hydrogen? What does that tell you about the amount of oxygen compared to the hydrogen? It's half as much. So therefore, if I was to take a look at the anode and I have 3 bubbles of gas that forms, what should you expect to see at the cathode side? If I have 1/2 to 1 and 4 the oxygen over here, I have 3 bubbles. How much H2 should I expect to see?
6.
How many bubbles?
6.
I should now see 6. So in this case over here, when you do your lab today, you should expect that one side is going to be bubbling twice as much as the other. Okay? Now, I'm going to give you another question. You're going to do this down here. And this will also be a sample question for another reaction you're going to do in today's lab. So over here, what I want you guys to do is you're going to do electrolysis of 1.0 molar Ki with carbon electrodes. What are you going to form at the anode? What are you going to form at the cathode? And what is the overall reaction? And what is the voltage? Good luck. Electrodes. So again, just like the previous question, remember when you have a carbon electrode for chemistry 12, if I say platinum or carbon, you assume it is inert. Okay? Okay. So as a result over here, when we now take a look, I've got now K plus, I've got I minus, and I have H2O. Now, what I'm going to do is I'm going to go into my data booklet, and all that I'm going to do is erase all of this. And then what I have over here is I'm going to look for my Ki. So I'm going to use, let me use green over here. So I'm going to look for Ki. So my I is over here. My water is over here. Down here I have my water, and then I have my potassium, which is here. Now, unlike before, what I can do is I can list them all out, but all I'm going to do is I'm just going to draw the circles for whichever species is already present in my system. And then all I do is I look at these two, and I go, they're both starting on the right-hand side. So if I take a look at these two values, which one is the smaller of the two?
2i.
0.54, isn't it? Okay? And then down here, notice that these two are also on the same side. So when I take a look at these two, which one is the smaller of the two? It's the 0.41. So these two now are going to be my two reactions that are taking place. So here I've got that uphill, yes? So that means this bottom one is going to go forward, the reverse one is going to go back. When this one goes backwards, that's oxidation, isn't it? So that's my anode reaction, yes? So therefore, if I go back into my equation, my anode reaction is going to be 2I minus, giving me I2 plus 2 electrons, and my E naught over here is going to be negative 0.54 volts. Now if I take a look at my cathode, which is over here, now this one is reduction, this is my cathode, so this is my water that is getting reduced. So I'm going to go back in here, and I've got 2H2O plus 2 electrons, giving me H2 plus 2OH minus, and my E naught over here is going to be negative 0.41 volts. So if I add this up, it will be 2I minus plus 2H2O, giving me I2 plus H2 plus 2OH minus, and my E naught is going to be negative 0.95 volts. Did you guys get that? Now, let's talk about what you will see in this reaction visually. So on this side, you've got the electrons coming out, and you got the electrons going in. So over here, this side is going to be your cathode, and this side is going to be your anode. So if I take a look at the cathode side, do you see the H2 that is being formed? So if you go into your data booklet and you look at the H2 that is being formed, what do you know about the state of H2? H2 is a gas. So therefore, when you now take a look at what's going on in the cathode, you should see bubbles forming. Now at the same time, and you guys are going to be doing this, is that if you were to put in some indicator, and your indicator was phenolphthalein, what color would the area around that cathode turn? Because think about it, in addition to H2, what else are you forming? OH. What do you know about OH? It's a base. And in the presence of a base, what color does phenolphthalein turn? It is pink. So in this case over here, you're going to begin to see pink that is formed here. Now what about at the anode? So at the anode, do you see I2 that is being formed here? So you look at your data booklet and you look at the I2, which is over here. So do you see that it's a solid? So therefore, theoretically, you're going to see I2, and then it's going to basically see, it's going to start forming stuff around it. Okay? So far, so good? So what I want you guys to go beyond is that, oh, I generated the question, no problem, to what would it actually look like. Now, here's the last one. I will talk about overpotential effect a little bit later on. Right now, I just want you guys to get used to this. So I have the electrolysis of K2SO4 with Ag electrodes. What's the significance of me now telling you that my electrodes are made from Ag? Huh? They are no longer inert. They are going to be part of your reaction. So therefore, if we were to take a look, we're going to have K plus, we're going to have SO4 2 minus, we have H2SO4 or H2O, and then you now have silver. So again, if you guys take a look at your data booklet, and now I was to clean this up again. Okay? To clean this up, again, if I was to highlight this, would you agree with me that I have my water, which is right over here? Here's my water. Do you guys see that? Down here is also my water. Down at the bottom is my K. At the very top is my SO4. So I'm going to circle it. Here's my SO4. Here's my water. Here's my water. Here's my K. Do you see that? Have I accounted for everything? No. I also have one more. What is it? The silver. So over here, I am now going to take a look at the silver, but now I'm going to circle this side. So do you see how on this, the top, I have these three now circled? Do you guys see that? But do I circle the Ag plus right here? The answer is no, because it's not in my solution. So that's why I don't circle that. And so the bottom over here is now my two reduction ones. So again, same principle. Out of all of these ones that are on the right-hand side, which one has the lowest absolute value? The silver. Out of all of these two that are going to undergo reduction, which one has the lowest absolute value? The water, right? So in this case, your reaction is now going to be water with solid silver. Okay? So again, the bottom one is going to go forward. It's going to be a reduction. Therefore, it's going to be at the cathode. And the top one is going to be oxidation because it's going to be pushed backwards. And it's going to be at the anode. Okay? So let's go back to our chart. So at the anode, I now have the reaction of Ag giving you Ag plus electron, and my E naught over here is going to be negative 0.80 volts. Down at the bottom, I've got 2H2O plus 2 electrons, giving me H2 plus 2OH minus, and I'm going to have an E naught over here of negative 0.41 volts. So if I was to add them together, I'm going to have to multiply this by 2. So now I have 2 H2Os plus 2 Ags, giving me H2 plus 2 Ag plus, and my E naught is going to be negative 1.21 volts. So do you notice the same routine? Look for the ones that get oxidized, look for the ones that get reduced, find the lowest absolute value. Now, let's translate this to what we will see here. Since this is negative and the electrons are going in here, this is the cathode. This is the positive of the electrochemical cell. Electrons are being removed. It's the anode. You guys see that? Now, if I take a look at the cathode, notice again, I am forming H2. If that's the case, what should I see forming here? Hydrogen gas. So I will see bubbles. If I put in phenolphthalein over here, what should I see forming around this electrode? Ashley. Thank you. Okay, thank you for checking. So in this case, if I take a look around here, what should I see forming around here if this solution had phenolphthalein in it? What should I see? I put phenolphthalein in it. It's forming OH, isn't it? So therefore, this side over here will start to turn pink. Do you see that? Now, what should you start seeing over here on the anode side? So you take a look at the anode side, what is happening? The silver is turning into silver ions, and when it turns into silver ions, the Ag is now going to go into solution as Ag+, yes? And it's going to leaving divots behind. What is going to happen to the mass of that electrode over time? It's going to decrease. So are you guys beginning to translate the equation to what you should be seeing physically? It's not just a theoretical equation, okay? And when we start talking about things like batteries, it's going to explain why old batteries leak. And we will talk about that later. Now, here is what I would like you guys to do for maybe the next 10-15 minutes. Right now, I've just introduced this to you. If I was to jump to the lab, you'll forget all about this stuff. There's no reinforcement. So what I would like you guys to try to do is the electrolytic cell on page 148. There's no answers in the back. And at the same time, if you just so happen to finish this really quickly, then I would suggest that you go into worksheet number 6 and work on all of those questions that involve an electrolytic cell, okay? This is a short time for you guys to reinforce what's just been introduced. Because I guarantee you go home, you're going to be studying for your electrochemical quiz for tomorrow, and then you're going to forget about today's lesson. So this is your chance for reinforcement. So I'm going to give you about 10-15 minutes to work on this, and then we're going to work on the lab after. Okay? Time is yours.